Sewer rehabilitation with Aarsleff CIPP provides a simple, cost-effective solution for a rehabilitation that would otherwise have been a lengthy, extremely inconvenient process for traffic, shopkeepers and others, as in this case where a discharge pipe is situated beneath private gardens close to houses. Excavating a pipe and replacing it in the traditional manner here would not exactly have been popular. The Aarsleff tube is suitable for the no-dig rehabilitation of wastewater and rainwater pipes, for example. The Aarsleff tube is used to rehabilitate pipes ranging from 100 mm to 2500 mm in diameter. In this case, the tube is installed from manhole to manhole. Whenever required, a thin plastic tube is installed first to protect the CIPP tube against infiltrating water. Then the impregnated CIPP tube is inverted into the host pipe by means of compressed air. The tube appears at the end manhole and will now be cured by steam. When fully cured, the excess tube is cut off and the old pipe is now lined internally with a CIPP tube with a strong and smooth surface that will last for many years. The old pipe is high-pressure jetted and CCTV inspected prior to installation, partly to detect where the lateral pipes are connected to the main pipe and partly to check whether the pipe is clean and ready for the installation. The inversion robot that is used to install the tube in the host pipe is rolled into position. First, a pre-liner is blown into the old pipe. This is a thin plastic tube that protects the following polyester tube against infiltration and exfiltration during inversion. The tube is fed into the existing pipe through the inversion robot. The polyester tube was delivered to the site in a crate packed with ice to prevent premature curing. The tube is removed from the container and introduced into the inversion robot. Attached to the inversion head and secured. The inversion robot is then run into position above the manhole. The tube is introduced into the manhole from here and positioned next to the pipe to be repaired. The pressure required to invert the tube through the hose pipe is created by the inversion robot and is inverted through the pipe by means of compressed air. The tube is on its way through the host pipe, sealing off the lateral pipes as it advances. But as this takes only a short time, the residents involved will not notice it. In other cases, when large multi-storied buildings or industries are involved, measures to divert discharge water are established. The tube has now reached the end manhole. An outlet to evacuate condensation and steam and a thermometer probe are established to enable constant temperature readings in the end manhole during curing. The data are transmitted to the computer in the installation van and form part of the documentation of a successful result. At the other end, the inversion robot is disconnected from the tube and steam hoses are inserted. The entire process is constantly monitored and registered on a computer. The mobile unit is equipped with a powerful compressor to supply pressure during the rehabilitation and a large steam generator that supplies enough energy to guarantee successful curing. CIPP lining requires limited working space on the ground, and pedestrians and vehicular traffic are not inconvenienced while the rehabilitation is in progress. The start and end manholes and any intermediate manholes are reopened after curing has been completed. A sample specimen of the lining is sent to the laboratory to verify that it fulfills the quality the customer has been guaranteed and in order to meet the standards set by the Danish Quality Control Scheme for pipeline rehabilitation. A cutter, which is remote controlled from the CCTV van, is now used to reopen the service laterals. When all laterals have been reopened, work is completed with a CCTV inspection. This is naturally carried out by a member company of the Danish Quality Control Scheme for CCTV inspection, simply called DTVK in everyday language. It's also worth noting that Aarsleff's CIPP linings have undergone 20,000 hours of testing to document a minimum expected service life of 100 years.